Okay, we're up to 122. So we're going to start us off with this exercise. I'm going to call it more of an exercise. It's more of like a review, but there's some new lingo that gets thrown at us. And here it is. Show that the two functions are inverses of each other. And then they give you this rule to prove it. In other words, we are going to compose these functions. So we're going to find out what g of x is, which is right here, x squared minus 2. We're going to replace it. If we do this correctly, our answer is going to boil down or whittle down to x. So let's go ahead and do this. So it's f of whatever g of x is. G of x is x squared minus 2. Now we have to take this and plug it into here. So we go, we plug that in wherever x shows up. So we plug it in right here. So we get x squared minus 2. I'll get a red marker out to show you the plus 2 comes from here. It's just coming along for the ride. You can see these cancel, so you end up with the square root of x squared, which is x. And that's what they told us it's going to be when we're done, if we do it correctly. But we're not done yet. This must also be true, and then we can say, yep, these two are inverses of each other. And there's more to that story, but this is just an introduction to this lingo and also how to check to see if they are. So now we're going to reverse it. We're going to take f of x, and we're going to put the square root of x plus 2 in right here. Now this says, put this into the equation defined by g, wherever x is. So we see this is x squared minus 2. So we have to take the square root of x plus 2 and put it in for x, square it, and get minus 2. Now, just like the square root of 2 times the square root of 2, remember we said the roots fly off? If we square this square root, we get x plus 2 minus 2. These cancel, and we're left with x. So because f of g of x equals x and g of f of x equals x, we go, aha, according to this rule, they are inverses of each other because they both boil down to x. Where's this x? Right there. Okay. Okay, so now they're going to build a little bit. So they're going to say, find this. First of all, what is this? If I look at that, I'd say, oh, I remember these problems. It's like a negative exponent. You just put it where it ain't, and you're good. That is not what this is. This is saying that this is the inverse function of f of x. That's what the symbolism means. Now the question is, how do we find the inverse function? Well, it's pretty simple. So first of all, we get started. I'm going to use purple marker for a reason by saying, okay, this is the same thing as y equals 2x plus 5. Grab a handy dandy red marker. Now to find the inverse function, what we're going to do is we're going to switch the x with the y. We're going to go x equals 2y plus 5. And now we're going to solve for y again. Watch this. Subtract 5, subtract 5. I'm going to spin the thing around. 2y equals x minus 5. Now I'm going to divide by 2, and I get y equals x minus 5 all over 2. Now here's the twist. As soon as we replace the x's and the y's, this thing became the inverse function. But you're not done until you solve for y. When you take that y out and you replace it with the proper symbol right there. Now essentially, what we're doing, well, I think we're just going to call her good there. There's more of that coming. I'm going to show you one more example. Okay, here's another example, just in case it was a little rocky the first time. So we start here, and we realize that this is the same thing as this. So these things are just f of x. But now I'm going to switch. So I'm going to make a line, just so my brain can go, aha, this is where it actually turns into the inverse function. And now I gotta solve for y. So I gotta cube this side, cube that side. I'm gonna turn this around. Y minus 2, because this absorbs this. And then we get x cubed. Add 2, and I get y as x cubed plus 2. Not done until I take this y. So remember, y equals this stuff. It doesn't equal this stuff. So what is this? Well, this is the inverse function of that. So I use the proper symbolism to demonstrate what it equals. And now we found the inverse function of this. Now I'm going to show you just a little something something on this example. I was going to show you a little something something, but it would have taken too long for this video because we've got a couple more things to talk about. Third example of this type of problem. So here's h of x. We're just going to first start by substituting it what it equals. And it equals y. Then we do the switcheroo. So I'm going to make this line. And I'm going to go x equals y plus 2 all over 2y plus 4. And now we've got a pretty big job ahead of us. We've got to solve for y. This one's not quite as easy. Well, that means I've got to get rid of this by multiplying it by 2y plus 4. And notice these are going to cancel, which is good. But then I got to do the same thing over here, 2y plus 4. Distribute, distribute, so I get 2xy plus 4x equals y plus 2. Remember, we're not done until we solve for y. So I want to gather these two on the same side so I can factor out a y. So I'm going to subtract y here, subtract y here, subtract 4x, subtract 4x. I'm going to bring my work over here. So I get 2xy minus y equals 2 minus 4x. I'm going to factor out a y. So I'd be left with y times 2x minus 1 equals 2 minus 4x. I'm going to divide by 2x minus 1, divide by 2x minus 1. These cancel, so I get y equals 2 minus 4x all over 2x minus 1. I'm not done until I realize, hey, I can't leave this equal to y because this equals y. So what does this equal? Well, I started with h of x, so now this turns into the inverse function of h of x because we switched the x's and the y's and we solved for y. So hopefully you picked up on that. So now we're going to piggyback that idea of inverse functions, but this is going to have a little different spin on it. So what you guys have been used to is stuff like this, where if this is theta, and this is 3 and 4 and 5, you guys are like, hey, find sine of theta. Well, that's opposite over hypotenuse, so you put 3/5, and then we'd pat you on the back. Now they want you to actually go through this process and find out exactly what that is. Now, don't be so quick to think that they're all 30, 60, 90s. In fact, it's not. If it was, if that's 3, wouldn't that have to be a 6? Because you double it, and wouldn't that have to be the 3 square root of 3? So don't just go, it looks like a 30, 60, 90. So what does this inverse function idea have anything to do with these? Well, notice, here's my angle. They can use x, y, z, theta, whatever, doesn't matter. And I look over here and I'm like, okay, there's my opposite. This is just my hypotenuse. Based on SOHCAHTOA, I need to use sine. So I go sine of x equals opposite over hypotenuse. Now, if you want to, you can reduce that to 2/3. So now, what does this inverse world have to do with anything? Well, if you take your calculator, I don't know if I can show it to you, but let's see, right above, you can't really see it, it's blurry. But I'll just tell you, there is a button on your calculator that says sine, and right above it is this symbol. Remember, this means inverse function. This is the inverse sine function, but this actually does something for us. We're telling the calculator we're going to go sine -1. We're going to type that in, and we're actually going to, it's going to tell us what x is, which is an angle. Now, make sure your calculator's in degree mode. So here I go, second sine 2 divided by 3, enter. It tells me 41.8. So angle x equals 41.8 degrees. So that's a legitimate function on your calculator that helps us solve these angles. Let's try this one. Here's my angle. This is my opposite. This is my adjacent, because this has to be my hypotenuse. Notice I'm not going to use that in this case. So now I'm going to use tangent of that angle. Tangent of angle y equals opposite over adjacent. So I need to know what angle y is. So really, in my calculator, I'm going to find that tangent button. I'm going to hit the second button, because I really want to engage the inverse operation, because the inverse operation is going to tell me what the angle is. So here we go. What I'm really going to type in is this, and it will spit out what angle y is. So here we go. I'm going to go second tangent 12 divided by 5, 67.38. So angle y, 67.38. I don't know where my glasses are, so I hope that's accurate. All right, I got one more thing to show you. All right, grand finale for this section. Now we're just going to kind of introduce you to factoring differences of two squares. So that's a perfect square. 49 is a perfect square. It's a difference of two squares. So when you see these and you're asked to factor it, you take the square root of the first one, put it in the first place. Take the square root of the second one, put it in the second place. One's a plus, one's a minus. If you don't believe that that works, FOIL it out. X times x is x squared minus 7x plus 7x minus 49. You notice these two cancel? So I'm left with x squared minus 49. So it works. One's a plus, one's a minus. Now this is a harder one, but don't panic. It's still a difference of two perfect squares. So here's my skeleton. One's a plus, one's a minus. Take the square root of that, which is 10y cubed. Remember, we go 6 divided by 2. You forgot that rule. And then we go 10y cubed. And what's the square root of x squared? X and x. Now, I'm not going to take the time to FOIL that out. It just works. Now, what about a sum of two squares? Well, students would try to go x plus 7, x plus 7, and that's a valiant effort. But if I FOILed this out, I'd get x times x, which is x squared, but then I'd go outside and inside, and I'd get 7x plus 7x, which is 14x, which is like, that didn't work. These are prime. You cannot factor a sum of two squares. They've got to be differences in order for you to be able to do something. I think you guys are ready.